Okay, at the top of these notes, linear and rational equations. The front side is linear, the back side is rational. Rational means fractional, we'll get to that later. On linear equations, there are some things that you should remember. There are three kinds of linear equations. One is conditional. If a linear equation is conditional, that means it has one solution, also known as a root. If it is an identity, it has an infinite number of solutions. And if it is inconsistent, there is no solution at all for that equation. Here are some things you need to remember when you're solving linear equations. Use the distributive property to remove parentheses. Eliminate fractions. There's a magic trick for doing that we will use over and over and over all year long, so you have to be sure you get it. It's multiply by the least common denominator. Multiply every single term all the way across on both sides by the least common denominator. And then we use addition and subtraction to get all the variables on the same side. We use multiplication and division. We pay attention to the order of operations. And then number 6 says optional. You can always check to make sure that your answer is correct. I'll show y'all how to use your calculator to to check sometimes. And sometimes just a quick mental check is also a good thing to do. So on number 1, this is a simple linear equation. It's linear because there is no exponent other than the understood 1. So to solve it, you've been doing this for a long time. We use opposite operations. Undo subtraction by adding 7. Whatever we do to one side, we must do to the other. And so then we have 4x equals 24. And then in order to solve for x, y'all can't be afraid to speak because the camera's rolling. It's all good. Is it going okay?
Yes.
Okay. So then to divide, now we have x equals 6. This equation is what we would call conditional. It is true with the condition that x has to be 6. That's the only solution that works. Check it mentally. 4 times 6 is 24. 24 minus 7 does give us 17. It checks. On the next one, we get to a little bit more complicated equation. We have variables on both sides of the equal sign. To solve it, we have to have all the variables on the same side. So I would probably move, I usually move so that I keep a positive number in front of x. So I have 2 x's on the right side. If I subtract 2x on both sides, then 5x, bring down minus 12, equals negative 9. Be careful to remember that the sign in front of the number is part of the number. Now what? Talk to me. Add 12, and then when we add 12 to both sides, now we have 5x equals positive 3, and we have to undo a multiplication by using division and divide both sides by 5, and so x equals 3/5. This equation is conditional. We found a solution. We found the only one. I'll give you an example in a minute of what it looks like when there's more than one. There's only one solution. This equation is true with the condition that x must equal 3/5. Let's check this one on your calculator. On your calculator, on the bottom left column, right above the on button, there's a button that says STO. Have y'all used that button before? It's the store button. Let's do this. Type into your calculator, and you'll have to type in 3 divided by 5. Doesn't hurt to put it in parentheses to get in the habit of putting fractions in parentheses. And then hit that store button. It's right above on. So do 3 divided by 5, enter, and then store that, hit the STO button, and I think it gives you an arrow, am I right? Store that as the variable x, so then just type x. Now go back and retype the left half of the equation. Do 7x minus 12, and when you do that, your calculator thinks you mean 7 times 3/5 minus 12. What'd you get? Negative 7.8. Are y'all not agreeing?
No, I just got error on mine.
I'll look at it in a minute. If you do 2 times x minus 9, what do you get? negative 7.8. So if you typed it incorrectly, you'll have negative 7.8 equals negative 7.8, and you verified when x is 3/5, you do get the same thing on both sides. Brianna, I'll look at yours in just a second.
Okay.
On the next one, we have an equation to solve. And we notice that there's a variable in 3 different places. 2 on the left side. So really what you notice is we've got some like terms that we can combine. If we combine 7x minus 5x, that's 2x, and then we still have minus 3. And on the right side of the equal sign, 10 plus 3, we can combine that, they're like terms. So we have 4x plus 13. Now we're back to the same place of having variables on both sides of the equal sign. I could either subtract 4x from both sides or subtract 2x from both sides. I tend to keep the variables positive, so I would probably on this one subtract 2x from both sides. Remember the sign in front of the number is part of the number, so negative 3 equals 2x plus 13. Now we're to a simple linear equation. We got to subtract 13 from both sides. Negative 3 and negative 13 is negative 16 equals 2x. And then divide both sides by 2. And x equals negative 8. Or negative 8 equals x. We won't take the time to check it right now. But you could store negative 8 as x. And then type 7x minus 3 minus 5x. See what answer you get. Then type 10 plus 4x plus 3. And you ought to get the same thing on the right half as you do on the left half. On number 4, it looks like a little bit more complicated equation. It has parentheses in it. If we distribute, that's the first thing we want to do. Well, actually, if we were looking for order of operations, we would ask ourselves, is there anything we could do inside the parentheses? Nothing we could do with x plus 2 or 4x minus 2. So the next thing we want to do is clear them out. Distribute, make the parentheses go away. So this 5 is multiplied times everything on the inside. That leaves me x plus 5x plus 10. And if I distribute the 3, that gives me 12x minus 6 plus 18. Now combine terms that are alike. So x plus 5x gives me 6x plus 10 equals 12x, and we can combine these two because they're alike, positive 12. And now we're to the same place we've been twice before. We've got an equation to solve. It has variables on both sides of the equal sign. You got to get all variables on the same side. So if we move 6x, if we subtract 6x from both sides, that's keeping the coefficient, the number in front of x as positive. But you don't have to do that. 10 equals 6x plus 12. And then if we use subtraction to undo the addition, and we subtract 12 from both sides, I'm assuming y'all are pros at this. I'm going pretty fast. But we end up with negative 2 equals 6x. And here at this point, I usually have people who will tell me the answer is negative 3. Is that right? Because to finish, we got to divide both sides by 6. 2 divided by 6 is not, yeah, we just have to reduce it. So x equals negative 1/3. We'll practice checking something like this a little bit later. You could store negative 1/3 in your calculator as x, and then retype the left half, retype the right half, compare them. You should get the same on both sides. On number 5, you notice that you have an equation to solve, and it has fractions in it. There are no variables in the bottom of the fraction, just numbers. So this is not really considered a rational equation unless it has variables in the denominator, but it's rational in the sense that it involves fractions. And so we have a magic trick. We're going to use this all year long, so it's an important one to learn. Anytime you want to solve an equation that has a fraction in it, you can multiply every term all the way across common denominator.
20.
You're gonna multiply every term all the way across on both sides by 20. So we're gonna multiply 20 times x over 4, 20 times 4 over 5, and 20 times 19 over 20. When you multiply every term all the way across on both sides by the least common denominator, 20, then instead of 20, I'm going to now think of this as being 4 times 5. And that helped me because I have a 4 on top and a 4 on bottom that cancel out and just leave me with 5x. This is 80 divided by 5. If I go straight across the top and straight across the bottom, 80 divided by 5 is 16. But you might not see that quickly, so it's probably an easy thing to do if you think, I'm going to think of 20 as being 4 times 5. And now I've got 5 over 5, so I can cancel those out and just multiply 4 times 4 to get 16. And on the right-hand side, 20 over 20 goes away. That's a 1. I can cancel it. They're factors. So 5x minus 16 equals 19. Then if we add 16 to both sides, 5x equals 35, so x equals 7. Let's take a minute and check this one. If I plug in 7 everywhere I see an x, I will have 7 over 4 minus 4 over 5, and I'm trying to decide, does that really give me 19/20ths back? If I was going to check this, I would need a common denominator for these two fractions in order to subtract them. So it's 20. I would have to say, to get from 4 to 20, I'll multiply times 5. So 7 times 5 means I have 35. To get from 5 to 20, I have to multiply times 4. So that means 4 times 4 gives me 16. Well, if I subtract 35 minus 16 and keep the denominator of 20, I'm trying to decide, is that the same as 19 over 20? 35 minus 16, that is 19/20ths. So I found a value of x that I can plug in and make that equation true. This equation is considered conditional. It is true with the condition that x has to be 7. This one was, everything we've done so far is conditional. We found one solution and only one solution. Are you okay? On example 6, we have an equation to solve. It has fractions in it. The magic trick we're going to use all year long is when we solve an equation with fractions, we want to clear them out. It has to be an equation before we can do this magic trick. It's an equation because there's an equal sign. This magic trick doesn't work if there's not an equal sign. So, what is the common denominator here? Yeah, because this is really 2 over 1. So the common denominator is 12, the least common denominator. That means I'm going to multiply every single term all the way across on both sides by the common denominator 12. Except instead of thinking of this as being 12, I'm going to think of 12 as factoring to be 3 times 4. Because then I have a 4 on top and a 4 on bottom that will cancel out. And that just means I need to distribute 3. And that will give me 9x plus 3. Are you okay? 2 times 12 minus 24 equals, on the other side, instead of 12, I'm going to think of it as 3 times 4. And then I have a 3 on top and a 3 on bottom, so all I have to distribute is the 4 equals 4x plus 4. Now on to an equation that looks like some of the others that I've solved. I have an equation to solve. It has variables on both sides. Here are some like terms that I can combine. 3 minus 24 is negative 21. If I subtract 4x from both sides, then 5x minus 21 equals 4. If we add 21 to both sides, then 5x equals 25. And then divide both sides by 5. To get x equals 5. I found a solution. There's only one. So this equation we would call conditional. It is true with the condition that x must be 5. We'll practice more on checking some of these later. On number 7, we have an equation to solve. It has fractions in it. We would like for the fractions to clear out because it makes it all easier. The magic trick, it has to be an equation. If there were no equal 3 here, I can't clear fractions. It's an expression. I have to actually get a common denominator and write it under each one of these original fractions and work with a common denominator. But as soon as there's an equal sign there, it's an equation, and now I have a magic trick that will make those fractions go away. What's the common denominator? 15. So we're going to multiply every term all the way across on both sides by 15. I'm multiplying by the least common denominator. But instead of thinking of this as 15, I'm going to think of it as 3 times 5. Because now I have 5 on top and 5 on bottom, and all I have to distribute is 3. So 18x minus 3. And instead of this 15, I'm going to think of it as 3 times 5. But that 3 over 3 will cancel. So I distribute 5 and make it 10x, and it's negative. And on the right-hand side, 15 times 3 is 45. Wouldn't you agree that that looks like an easier equation to deal with than the one we had originally? So clearing fractions makes things simpler to work with. 18x minus 10x, those are like terms. That gives us 8x minus 3 equals 45. Then add 3 to both sides. And 8x equals 48. And divide both sides by 8. So x equals 6. We found a solution. There's only one. We haven't come across one yet, but we're going to in a minute. So if there is only one solution, we say the equation is conditional. This equation is true with the condition that x must be 6. On number 18, here's a common mistake. I'm going to steer you away from it. A lot of people are really tempted to say, 13 minus 4, that's 9. Now I'm going to distribute the 9. Is that okay? That's the wrong order of operations. You can't subtract until after you have already done, please excuse my dear Aunt Sally, until after you've done parentheses. There's nothing we can do inside these parentheses. Please excuse, there are no exponents, but that does mean we have to multiply and divide before we add and subtract. Now here's the thing you also have to be careful about. The sign in front of the number is part of the number. So when you distribute, you got to think of it as distributing negative 4. So this one looks like 13, and when you distribute negative 4 times 5x, that makes it minus 20x, and negative 4 times positive 1 is negative 4. On the other side, we just have a 3 to distribute to get 21 minus 15x minus 15. Combine things that are alike. 13 minus 4, 9 minus 20x. On the other side, 21 minus 15, that's 6 minus 15x.